Okay. So 1.6 is just all kinds of different types of equations. It could be absolute value, which is the first one we're going to do, first few. We also have rational expressions, which are the fraction type problems that I guess it's like variables with fractions. Okay. And you got to cancel the fractions. You got to solve for x. And there'll be some other types. Let me scroll down here. There's quite a few. There's removing higher powers, rational, square roots. It's a lot of different kinds. It's kind of like a big review on solving for X, but just every type. Okay. So I'm gonna go use the notes that are in the unit one. I'm just gonna solve most of them. Not all of them, but most of them. All right, so let's start here. So first thing is whenever you have an absolute value, we have absolute value of u. You want to get this part by itself. Okay. So we gotta add the 20 over. Let's add it over. Once it's added over, then you remove the absolute values. So 20 minus 11 or negative 11 plus 20, that is 9, right? These are the properties we're going to use. And I'm going to record this and scan the notes. Okay. So I'll send them to you either after class or tomorrow morning. Okay, so in order to remove it, check it out right here. It says absolute value of u is equal to k. In order to remove it, you have to write two equations. So once it's gone, you put u equal to that number or u equals to that same number. So this is what we're going to do. U is equal to 9 and or u is equal to negative 9. So you just solve two different ones. Although on this one, there's not much to solve. It's already done. We have two answers. Does that make sense? Do you see what happened? Okay. So just let me know if at any point I don't make any sense. I'll add more details or explain it a different way. Remember, you're here to ask questions, so don't feel bad about that. It would be a shame if you stay quiet and ask nothing if you need to ask. Okay, so that's number one in your notes. So the next one, the same type of stuff, is a little more complicated. Let me see if it might fit right here. Okay. So remember we said, I'm sorry, I'm a little tired. I'm still kind of sick too. Got the flu this last few days. To give me some grace. So in order to remove the absolute values, isolate the part that has the bars. Okay, so the bars are the absolute values. And back in the day, we said whatever is in there must come out as a positive. Um, but if you want to remove them, you have to account for the possibility of a positive and negative because you could plug in 9 and get a positive. Plug in a negative 9, you get a positive 9 because that's what the absolute values do. You guys remember what the absolute value is? I'm assuming you do, so I haven't explained it. If you don't, let me know. Okay, so the definition basically means any number that goes inside must become positive. So if it's already positive, then nothing happens. So for example, Absolute value of 2 is 2. Absolute value of negative 2 is equal to 2. It's also defined as the distance away from 0. So if you had 0, 1, 2, negative 1, negative 2, how far away is it from negative 1? See how this one is 2 units away? And this is 2 units away? That's what it means. What is the distance from 0? What is the absolute value? What is the positive version of whatever this is? That's all the same thing. But to do the work, we have to use these four properties. Or, maybe just one or maybe two. But we said in order to remove them, you first have to isolate the piece that has the two bars. So let's start there. So in example 2, and 60 on both sides, we'll get to right here. And 60 plus a negative 8 or negative 8 plus 60, that is a 52, right? So this is supposed to be a U. And if I skip too many steps in the algebra and you want extra steps, let me know. Is this okay? Remember, I can't tell if you guys know everything or if you know nothing. So you got to tell me at any point. I have no idea. Yeah, it's no big deal. So, so we're trying to isolate this part, right? So there's negative 60s in the way, so I'm adding 60 to both sides. So what happens when you add 60 to both sides? My ugly you. Yeah, so this 60 will cancel because I'm gonna add another 60. And then I gotta add this 60. So these are gone, which was the whole goal, which gets us to the step I was at earlier. See what I mean? Since we have an equation, whatever I do to one side, I have to do to the other side. I added 60 because I wanted to cancel this term. Negative 60, the opposite is positive 60 on purpose. It canceled, but I got to deal with the other side of the equation. Negative 8 plus 60 is 52. So now we've dealt with this term, right? Does that make more sense?
Yes, yes, it does.
Okay, so now that we're here, there's still a 4 in the way. What is this operation? What is the 4 doing to the absolute value part? Yeah, it's 4 times that, right? Since there's no symbol, we assume it to be a product. It's 4 times the absolute value of 2u plus 7. That is in my way. So how do I get rid of the 4? Yeah, so if I want to cancel a product, we have to divide. So right here, divide by 4, divide by 4. These are gone. 4 divided by 4 is 1. So now I finally isolated the piece, the absolute value part. What's 52 divided by 4? I don't like arithmetic, so I don't do that stuff in my head anymore. 13? Yeah, that sounds right. Okay. So Now we're back to example one, right? Remember how we started? Pretty much started there. Almost. Once you have it by itself, what do you do to take them off? Take off the bars. What do you think is going to happen here?
Would we have to do the same thing as the top?
Yeah, what was that?
We have to get rid of the 7.
We gotta get rid of what I'm asking is we gotta get rid of those bars. How do we do that? So look at property number one. So before we do all that other stuff, we gotta remove the bars. In order to do so, we gotta create two equations. Whatever's inside the bars equal to the other side, and then another one equal to the negative version of that side. You see what I mean?
So with these problems, there's always going to be two answers.
Yeah, pretty much because of I would say most of the time. We're gonna have two things to set up. Most of the time you'll get two answers. So removing those bars requires you to create a negative and positive version. Does that make sense? So if we follow number one exactly, right, it says whatever's in here equal to the other side, and then the other one, whatever's in here equal to the negative version. And then just solve for the variable. So
Okay.
old school, like, solving for x.
I
Okay,
see.
so is this part okay?
Okay. Yeah.
Yeah, so we're using property number one at the very beginning. Running out of space. I'm gonna skip a little bit. So you see how you would subtract 7. What's 13 minus 7? And then divide by 2, right? Sorry, my youth looks ugly. It looks like my 6 and 4 at the same time. I don't know how I did that. So the other one, negative 13 minus 7. What's that going to be? Negative 20 divided by 2. So I couldn't show the little tiny steps, but that's how you get this. Okay. Any questions on number two? Well, what do you mean, Jonathan? By same numbers? In our case, 13 is the K. So we get 13 and negative 13 as the beginning setup. But when we get there, we have to do algebra because on this one, there was nothing to do. It was already solved. You see the difference? Here, it's not solved. So we have to isolate U on both. So 2 is a more complicated version of number 1, but it's the same thing. This one just had a lot more algebra to do because you can't use the property until this part's by itself. Does that make sense? Any other questions on example 2? Okay, so let's do number 3. It's very similar. That'd be the last absolute value, and then we'll move on to a different type of equation. So this section just keeps throwing different types at us. Some are kind of chill like these, and then some are kind of hard, I guess, like the fraction ones. I already know most of you are not gonna like the rational expressions, but if you're a pro at fractions, then you'll be good. And if you're not, then you're gonna hate it, and you're gonna have to get good. But I know we all like to avoid the things we don't like, which makes it worse. We're all aware of that. I do it too, so I'm not talking trash. Okay. I just don't do it with math. I do it with real life stuff. Okay, so this is property what? If you look at the very top of the properties, which one is this? If you have two absolute values equal to each other, what do we do? Yeah. So basically, we said you just set the insides equal to each other, positive and negative. So put the minus on the right, and you'll be good. Excuse me. So the left-hand side equal to the right-hand side, and then this side equal to the negative version of the right-hand side. But notice I got to put the whole negative on the entire thing, or the negative on the whole thing, sorry. Does that make sense how we set it up? Property 4. Just doing what it said. Okay, so now that it's set up, we just do algebra. Although, what do you notice about the left-hand side type? Yeah, the whole y's are going to cancel. What does that mean? Yeah, whenever the y's are gone and you get a false statement left over, you have no solution. But let's show the work, all right? Let's say I want to get all this stuff to the left-hand side. As soon as you subtract the y's, they disappear. Does this make sense as a statement? This is a 5, by the way. I just can't write. That is a false statement, right? Negative 5 is not equal to negative 7. So this equation means no solution. So whenever you see something that just doesn't make sense, 0 equals 5 or something that's not equal to something, just false, no solution. Now, if you were to get negative 5 equals negative 5, that's very different. That would mean you have infinite solutions, but that's probably not going to happen anytime, very often, but there are three scenarios, right? No solution, one solution, or infinite. Okay. Well, technically, one or more solutions, no solution, infinite. So you could have two at most for absolute value. Sorry, I got to be very precise in mathematics. Okay. It's the one time where you got to be like, well, actually, that's when you do it. Math in math. Be that guy. All right, so solve for y. This is not going to cancel, right? You guys cool with this first step? Any questions on how I got to from this line to that line?
How did you get a positive 7?
So I added 4y to both sides, so I can cancel this. You see why I chose that?
Yes.
So once this is canceled, what's left over?
No, but why would, okay, I see the negative 7 up on the top. So where do we get the
Oh,
positive?
you're talking about that part. I'm sorry.
No, you're good.
You have to distribute the negative on both. So positive 4 becomes negative 4, negative 7 becomes positive 7. So this negative swaps all your signs.
Got it. Thank
That's
you.
why we get to here. Okay, at this point, add the 5 over, right? Oops, ugly fives. 7 plus 5, that's 12, right? Yeah. What's the next step? Yeah, just divide by 8 and we're good, right? Yeah, and simplify, that's true. 12 divided by 8 becomes 4 reason above. Yeah, you're right. Um, Jonathan, you got it. So we only have one solution on this guy. Any questions on either one? Yeah, we got to simplify because it's most likely going to mark it wrong. I mean, I would give you full credit, but can't trust online homework. Any question? No, you guys are cool on three? Yeah. Oh, shoot. There we go. Yeah, this section is I think one of the harder sections. Next section is super chill. First two are okay. Let's say, yeah, first two are kind of easy, and the fourth is kind of easy. The third one is the only one that's kind of hard. Okay. I don't like using the word easy, but if I had to pick which one's the hardest, I'd say it's this section. If that makes sense. And if this is simple to you, then that's good news. And if it seems impossible to you, then that just means you gotta practice and you'll be okay. Math is all about practice, okay? The more you practice, the better you get. It's not about cramming. That's why people hate math because you can't just cram and be good. You gotta practice little by little. It's like the guitar, or piano, or basketball. But you gotta practice or you're not gonna be good. Anyway, let's move that 32 over. Sometimes I like to think about I'm just gonna move it over and switch the sign. Technically, you're doing plus 32, but after you've done it so much, you can just move it. Just think of it as, you know what, I'm just gonna move it over there and make it positive. Let's not overthink it. But whatever. You can think of it however you want. Now, in this type of equation, because we're moving on from absolute value, we want to cancel higher powers. This is the next technique. If I have a cube root, you want to cube root both sides to cancel a cube power. Okay, so these will be canceled. Now we got to deal with the cube root of 32. I think that's going to be 4, right? Oh man, my calculator died. 4 times 4 is 16 times 4 is 64. So no, that's not going to be pretty. Yeah. So we got to pull out a cube power. The smallest cube is 8. 8 times 4 is 32. Do you agree? And what is the cube root of 8? So this cube will apply only to this one because the 4 is not a cube. So this will become 2 cube root 4. Move the 8 over, and we're done. We can't do anything else. It's not a very pretty answer, but that's it. The 32 is not a perfect cube, but it can be reduced by pulling out a cube. The 8 becomes a 2. The 4 is not a cube, so it stays in there. I subtract the 8 on both sides or move the 8 over, however you want to think about it. U is equal to negative 8 plus 2 cube root 4. Is any of the algebra not clear to you? Add some extra notes for you, just in case. Just in case. Be careful, Jonathan. This is 2 times root 3, 4. All right, order of operations. So you can't, you got to multiply first and then subtract, right? Or then add. So unless you were to first deal with this, you cannot combine the negative 8 with this. The 2 came from cube rooting the 8. Yeah, let me go get another calculator. Uh, Damn. Apparently, all my calculators are dead. I'm using my phone. Hopefully nothing weird pops up on my phone, otherwise I have to delete this whole video. All right, so 8 cube root, right, is 2. So, what you can think of an extra step here, there is a property that says you can separate these to reduce your radicals. So if you have a cube root, you want to look for a cube inside your number as a factor. And I knew there was an 8 in there. So think of all the cubes. I don't have them memorized. I have the first couple, like 8, 27, 64. That's about it. I don't remember anything after that. After that, I gotta start using my calculator. So then when I saw the 8, I'm like, okay, well, we can reduce that guy. Cube root of 8 is 2. I cannot do anything with this. So I just left it alone. And then I said, well, I'm solving for you. That's the whole point of all this. Minus 8 on both sides. So u is equal to this nonsense. This is the exact answer. It's not pretty. If you punch this into your calculator, you get a decimal. I don't know what it is, but you get some number. But the exact answer is this. If the question does not mention rounding, then you need to enter this. If the question says round to the nearest whatever, then just plug this into your calculator and do so. Okay? Any other questions on 4? Alrighty. 5 is moving on to a different type. These are the rational expressions. So I'm hoping you guys are all pros at fractions. I hope, but I doubt it. And don't feel bad because I have people in calculus who don't know fractions. And that's okay. You just got to figure it out before the class ends, right? I'm not gonna judge you. I mean, I just want you to figure it out. That's all. I'm not an emotional guy. I'm just a very logical person. If you figure it out and get it done, I'm happy. You're good. Okay. So you gotta solve for V, but notice how V is under the denominator, which kind of sucks. Excuse me. So whenever you have equations, you can cancel all your terms by multiplying every single, oh, I'm sorry, you can cancel all your fractions by multiplying every term by the LCD. Can y'all tell what the LCD is by looking at this? I know it's so the rules are the same as numbered fractions and fractions with variables. But if you were struggling with the numbers, then this is a little harder, but it's technically the same. So remember, or recall, what's the LCD of 2 and 3? They're prime. Why did you choose 6, Jonathan? Why is it 6? Yeah, so if so one easy way to do it. If every denominator is prime, then you multiply by every denominator on every term. Now, a quick reminder. Yeah, I keep getting these stupid ads on my phone. Um, quick reminder. Let's see. Make up a question for you. If I had 1/6 plus 1/8 equal to 1 over x, I guess. Oh, it's okay, Jonathan. You want to multiply by, you gotta first factor everything if it's not already factored. Then it becomes a little more clear. You agree that 8 is just a bunch of 2's, right?
Yes.
So the way you should think about it is start with one factor, the smallest one, or whatever. It doesn't actually matter. I'm gonna start with two. At most, how many twos appeared here? It's not a trick question. Over here we had how many? So at most, at any given location, we had three. Over here we had zero. So the LCD is going to be for sure three of these, or two cubed. How many threes came out here? Over there. And here are both zero, right? So the most that appeared in any given location, remember, it's not the total, the most in one spot, one. And we have a single X over here, one. So the LCD will be 24X. So what you do is you factor everything into primes. This works for any fraction all the time, every single time. This is the way you should do it. Yeah, it looks a little harder. I know some of you are like, well, I can just do it in my head. 6 and 8 goes into 24, blah, blah, blah. But no, when we start doing v minus 2 and v minus 1, tell me what do these two divide into in your head? It's not easy, right? You see my point? Why I did this nonsense? Because you can't, unless you're very gifted, divide this in your head, right? Do you see what I'm saying? Or no? So once you find this number, you multiply every single term by that number, and you will no longer have fractions. You'll be done. But these are already prime, and this has a 1 underneath. For this example that I just made up for you, and you'll see why. Let me go ahead and do it for you. We'll come back to this later. See? Sorry, emails are coming in. All right, so here we go. So check it out. All these fractions will cancel. What is 24 divided by 6? The x doesn't go away, but yeah, 4 times the x. What about this one? 24 divided by 8? So 3 times the x. And what happens here? Yeah, these are gone, right? So the goal is to identify the LCD, multiply every term, and then have a basic ass question where it's no longer a problem. You see what I'm saying? You see the goal with this is identify the LCD and get rid of this nonsense because it looks really hard. But if I get rid of the fractions, then I have something more manageable, right? Yeah, so that's what we're trying to do. So this was like a little reminder. Okay. So let's go ahead and do this on the next page. Do you have any questions on this more simplified version of number 5? No. Okay. Let's go and do the actual question now. Okay. Do you agree that v minus 2 have nothing in common? They cannot be factored. Do you see anything in common with v and 2? Do you guys see what I'm asking or no? Do you see why we can't? Or do you think you can? Yeah, so for example, let me just remind you, like if we had something like this, you could pull out a 2, right? That would be considered factorable because they have a 2 in common. These have nothing in common, right? Except a 1, which doesn't do anything. So since it's prime, then the LCD is just these things multiplied together. It's actually pretty simple. You don't got to do anything. Now, so he is just this. So multiply every single piece times this. Now, if you could factor, then you'd have to talk about these kinds of ideas right here. Like, oh, how many twos, how many threes, how many v minus twos, how many v minus ones, how many b's, that kind of stuff. But we can't factor anything, so it's prime. When it's prime, it's much easier. You see where I'm going with this? Okay. So now that I'm here, what's going to cancel in this? Oops. No, nothing's going to cancel on the first one, right? There's no fraction there. So we'll just leave it there for now. What cancels here? If you don't see it, I'll add one additional step. Is that more obvious? Or does it help? You see what I mean? No more fractions, right? Mhm. So now we have a simpler problem. Any questions on the steps up to this point? They are all V's, by the way. At this point, distribute, multiply, combine like terms, solve for V. That's the goal after this. Because once you get rid of the fractions, we have something that's more manageable, right? Okay, so here we go. Multiply these guys out. We're going to get, I'm going to put a bracket just so it's clear. V times V, V times negative 1, negative 2 times V, negative 2 times negative 1. There we go. Distribute this. That gives plus 5V minus 5, negative 2V plus 4. Any questions on the algebra before I move on? So you guys see that multiplying this out gives us this. Distributing the 5 gives me this. Distributing the 2 gives me that. Okay. Now multiply. Oh, well, let's go ahead and combine like terms. Okay. Distribute the 6. Now we just combine like terms and start trying to solve for v. Negative 18v plus v, or 5v, that'll be 13v. 12 minus 5. That's what, 7? Is that right? Probably. No, there's no rush. I mean, okay. So now just remember to solve quadratics, you have to move everything to one side. In other words, set it to 0. So I'm going to move the 2v over and the negative and 4 over here. So subtract 4, add 2v. So now we get to here. Any questions on the algebra? I'll wait a sec. So at this point, factor this and we're good. I don't think there's an easy factoring technique other than AC method. So remember that all right, this is general form for quadratic equation equal to 0. Then our A is 6 and our C is 3. A times C is 18. This is the technique we're going to use. If you mean the quadratic formula, you could, Jonathan, but This one would be less work, but I'm not gonna. If the instructions don't say how to factor or solve, then you can use any technique you want. Factors of 18 that add up to -11 is the goal. So this is the video I sent you before. Um, in order to get negative, you have to do 3 times 6, -3 times 6, or 3 times -6. 2 times 9, or 2 times -9. And then over here you add them, add the products. So -3 plus 6, 3 minus 6, -2 plus 9. Oops, I made a mistake. It has to give me positive 18. These factors do not give me positive. Only way that would happen is if they're both negative, because they have to add up to a negative and they have to give me a positive. And the only way that happens is if they're both negative. And if you don't remember this technique, it's in the video, so just watch that later this week. And it's okay. I don't feel bad or anything. There's You could do trial and error and force your way through, or you could do quadratic formula. Quadratic formula. Okay, so add them up, you get -9 and -11. So once I get this term, that's the one we're going to use. This is the sum of factors. All right, guys. A bunch of remind messages. Okay. So once you set this up, you're going to break that middle term. Oops. I think I'm gonna have to go to the next page. There's not enough space for this. Let me rewrite it on the next page. Sorry, I shouldn't cram it in there. It's just not clear. And we chose the two numbers, -2 and 9. So it'd be -9v minus 2v. There we go. Let me get in the camera there. Oops, wrong button. All right. So the goal, right? Let me feel like we got kind of sidetracked there. Do you all remember factor by grouping? It's an old school. I think you first did it in middle school. So if you forgot, it's okay. A long time ago. I'm sure it came up in high school and maybe your last math class as well. When you group four terms at a time. Is that familiar? And so the way the AC method works, again, if you haven't seen the video, it's okay. You take the A and the C, you multiply them together, and then you write down the factors of that number that are going to give us the B term. B term is the middle term. Once you have the numbers that add up to the B term, which is -2 plus -9, right? Then you break up the middle term and you get this. Once you have the four terms set up, you can do grouping. So basically, you say GCF of each one. So what's the GCF of these first two terms? What does 6v squared minus 9v have in common? Yeah, for sure they have a 3. What else do they have in common? Just the first two. I don't mean LCD. I mean just what can I factor out of both? 3 is correct. Uh, but other than the number, what else do they have in common? Yeah, the V, right? But they both have a V and they both have a 3 in common. What about these two? They have nothing in common, right? They're both prime relative to each other. But notice how this one's plus minus and this is minus plus. Yeah, so they got to be the same sign. So factor in -1. So here we go. If I factor 3v from the first term, what do we get? Yeah. Does everyone see why it's 2v minus v? Actually, minus 3, yeah. If I factor a negative to the other one, what happens to the signs? Yeah, remember? Because that's what you do with GCF, right? You factor it out, and everything inside changes. If I pull out a -1, what happens to the signs? They're gonna swap, right? Now, at this point, we're ready for the final step of grouping. What do these two have in common? This term and this term. Yeah, so just pull that whole thing out, and what's left is this guy. Does that make sense? Now we have two factors equal to 0. What's the next step? Right, the zero factor property says set each one to 0, right? Add the 3 over, add the 1 over, divide by 2, divide by 3. Any questions on the algebra that I did not show? I'm trying to show extra steps just in case your factoring is rusty. So just let me know anytime if anything's weird. I'm gonna skip number 6 and go to number 7. Are y'all cool with this number 5? Oh, picture this. Like if I had 3VW minus 1w. Do you agree that I can factor the w? Jonathan? You don't agree. Like if they both have a w in common, I'm going to pull out w from both. The GCF. Just not even worry about the zero. So think of this as some w term. Doesn't matter. I'm factoring that out from both of them here, which leaves me with 3v minus 1, which is there. If I factor w out of both, I'm left with 3v minus 1. You see what I'm saying? Does that make sense or no? To just treat it as some term that they both have in common. I'm just factoring it out of both. I don't care what that term is, whether it's a w or a triangle or 2v minus 3, they both have it. So I'm going to factor it here, here. And then the leftovers always go in the parentheses, right? Once you've done that, you just do your zero factors, solve for b. All right, give me one moment. Let's take a 5-minute break and then we'll do a couple more problems and we'll move on to something else. Be right back. So always check if they can be factored. If they can't, then you're good. This side can be factored. So what's the LCD when you see this? You see all three fractions. Yeah, so how many W minus sevens appeared? One and one. So at most we have one of them. W minus three appeared once and once. We have one of those. So the LCD will just be simply those two products. Okay. So this is what we're going to multiply every fraction by. This one, and that one. See how now all the fractions will be gone. Any questions on that part? All right. We end up with 6 minus 3 plus w times w minus 7 minus 12, actually, equal to negative 12. So now no more fractions, and it's much simpler, right? Distribute the 6, distribute the w, combine like terms, and then solve for w. So we're going to get 6w minus 18 plus w squared minus 7w equals to negative 12. Combine like terms, we're going to get, I'm going to put the w squared in front. Negative 7 plus 6, that's a negative w. Combine those. I wrote that already. Minus 18. Putting a line through the ones I already wrote down or combined. Now I'm going to add the 12 over. We get negative 18 plus 12 is negative 6. What are the factors that will add up to negative 1? Factors of negative 6. Yeah, looks like negative 3 plus 2. Set them to 0. And then that's it. The only thing is when you're doing rational expressions, always double check with the original. What would happen if I put a 3 in here? Right, the original? Yeah, we would get division by 0. So if that happens with any of your solutions, we can't use it. So we only have one solution. Does that make sense? Do you see why we can't use it? Okay, so from the top, right? Find LCD, multiply by the LCD in every term, cancel all fractions, solve for W, which requires factoring, because we're going to end up with a quadratic. Sometimes one of the solutions or both will not work. So you got to double check by looking at the original and seeing, well, can I use them? I can't use three. Two is no problem, but three is a problem. All right, we're going to move on to solving radical equations. And if any of y'all feel intimidated, remember, like I said, this is one of the harder questions, one of the harder sections at the beginning. There's just so many different types. It's kind of like throwing all the basic equations at once, you know? All right, so the next one, can y'all see the notes that I'm following? I'm hoping y'all have it open too. This is 1.6. Solving a radical equation. So we're going to do some of these. Isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. Once you've isolated, you square both sides or you raise the power of whatever it is. So if they're cube roots, raise it to 3. If it's fourth roots, raise it to 4. If it's square roots, then square. If you end up with another radical, then repeat step 1 and 2. So this is the same. And once you're done, you need to double check if the solutions are cool because you're squaring a bunch of times, so you might introduce a fake solution. Okay, so we're gonna do number 8. We'll do both, 8 and 9, then we'll move on to something else. I don't know, we'll see. Okay, so step 1 said isolate the radical. So the one with the root, get it by itself. Once it's by itself, you raise both sides to whatever root this is. So if it's root 2, square root, and square both sides. If it was a cube root, cube both sides. So isolate this guy. So this will cancel, leaving me with this guy here. Now we can solve for W. Does that make sense? So whatever root we got, choose that power. Okay. If it doesn't, let me know. I know it's getting late, but there's a lot in here, and I'm trying to shorten it up for you. Add 26 on both sides, and then divide by 5. Yeah, looks like you're right. Looks like 7 to me. Look at the original. If I plug in 7, does that cause problems? 5 times 7 is 35 minus 26. Doesn't cause any negatives, so we're good. If your solution, when you plug it in, causes a negative in here, it's going to be a problem. You can work it out to be sure, but honestly, if it's positive, you're pretty much good. And it looks like the rest are the same. I want to move on to 12. Check this one out. So I have a cube. So what do you think I got to do? Yeah, so we got to cube both sides. Okay. -3 times -3 is 9. Positive 9. 9 times -3 is -27, right? Solve for V. Subtract 8. 27 minus 8, what is that? Negative, I'm getting tired. 35, right? Divided by 7. Yeah. This one, well, actually, you can have negatives in cube roots. You cannot have negatives in even roots. So second root, fourth root, sixth root cannot have negative inside, but odd roots are okay. You could plug it in the calculator and it'll be fine.
Can you say that once more about the odd roots?
So you cannot square root, or you cannot do an even root of a negative number, but you can do odd roots of negative numbers. Because we always, and most time you, I'm sure you all remember, oh, you can't square root a negative, right? You hear that all the time. But nobody talks about cube or fifth root or seventh root. So the general rule, the bigger rule is no negatives inside even roots. Negatives inside odd roots is fine. In fact, let's do it ourselves, right? See what happens. 8, negative 8. Cube root of that is a negative 2. See what I mean? 4 negative square root is a problem. So even roots cannot do negatives, but odd roots can. Righty. Quick note, in case you've forgotten, nth root of x is the same as x to the 1 over n. This is back from the rules of exponents and radicals. If you have nth root of x to the m, you could put the m outside, or it's the same as m over n. So if you see a fraction power, it's actually also the same as a root. So you could have said, example, cube root of 7v plus 8 is the same as 7v plus 8 to the 1/3. Does that make sense? It's all the same. Okay. So I'm going to skip a couple because I'm running out of time here. But I'm open to questions. If check this out. Can you see the notes I'm going over? Okay. So do you understand that in order to cancel the 1/3, I'd have to cube both sides, just like I did cube on this one. You see how these two are actually the same? I mean, there's a little extra step, but to cancel a cube root is the same as canceling a 1/3 power. Is that clear, or do you want to see this one? Does that make sense? Want to do it? Okay, yeah, no big deal. It's pretty short anyway. Here, check it out. Too many cameras. Okay, so just like you did the root, isolate the 1/3, subtract the 4, then raise both sides to the cube. So these cancel, leaving you with 6w minus 4. Negative 4 cubed is going to be negative 64. Okay. So at this point, isolate the w, add the 4, we get to negative 60. Divide by 6, and we're good. There we go. W is equal to negative 10. Do you see how it's the same? It's just instead of a root symbol, you have a 1/3. No, m can be anything. It could be a 2/3. So it would basically be like a square. If it was a 2, it would be a square. So you could cancel these, but then you'd have a square waiting for you. Because remember, we said we can apply the m inside or we can apply the m. Oops, I didn't write it. Shoot. After. So deal with this and then do the m. But if it's a 1, you don't have to worry about that. If it's a 1, it's just like the cube root. We'll do one that has a different m right now. Any questions on 13 though? Let's do 14. It has a 4/3 on it. So I'm just trying to give you guys some time. I think I'll record 2.1 and send it to you to save time. 2.1 is super easy, so you'll see what I mean. It's just plotting points like X and Y, like back in the day. Pretty chill. This one's just a little, this one feels hard, I think, to some of you because it's a lot of different ideas all at once. It's like a lot to refresh on. Does that make sense? If you feel it's easy, then no worries, but I feel like it could be hard because of that. So what you're gonna do in order to cancel is raise it to the opposite, the reciprocal power. You see what I mean? Okay. So the reason, remember the rules of exponents, right? If you have, let me rate that better. If you have a power raised to a different power, then you multiply them, right? So if I want to cancel a fraction, do you agree that if I multiply these, they will cancel? So hence why I chose 3/4 on both sides. So these will be gone. These are going to deal with this. So 3 to the 3/4, it doesn't simplify. It's a calculator question, whatever that is. My calculator's dead, so you would solve for V by adding 3. So that's it. If you use a calculator, you get like a decimal. Any questions on 14? Which part? This part from here to here? Tiara? So I'm solving for V, so I just did +3 +3. So I'm moving this 3 over here. So there it is. These threes are gone, right? This right-hand side is 3 plus that. I can't combine them unless you use a calculator to get an approximation. But this is the most exact you can get. I mean, I'm cool with that. If the, let me see what the instructions said. Excuse me. Let's just simplify as much as possible. The answer key for number 14 says, no, they leave it like that. They they go one extra step. They say, well, this is the same as the fourth root as 3 cubed, which is 3 plus the fourth root of 27. I mean, I'm cool with this though, but I don't know what the homework will prefer. But technically, these are both right. All three of these are right. I don't feel like the last one is more simple than the first one. But the question says simplify as much as possible. So I think that's good in my opinion. It does. If it marks it wrong or tells you to correct it, then just adjust it. Or let me know if you can't adjust it, and I'll try to fix it for you. Okay. Okay, 18 is substitution. This is a long section. So notice you have something squared and then the same thing not squared. So this is basically a trinomial. You have to do substitution. So use substitution and make this easier. Let u equal this. Then that would mean that this is u squared minus 16u equal to negative 64. So, so I set it to 0 and factor. What does this factor into? Yeah, it looks like 8 twice, yeah. So u is equal to 8, but we made up u, so bring this substitution back. Bring what u actually is, because we're trying to solve for x. U was just made up. They call it a dummy variable. So add the 17 over 8 plus 17, that'll be 25, right? Square root both sides. We're running out of space here. Whenever you square root, you have to tack on that plus or minus. So we get two answers, plus or minus 5. Any questions on 18?
Okay, so did we just do like one step at a time? Like we just broke it up into two pieces?
Um, well, we basically changed the question using substitution to make it easier. So look at the first part. Because this looks crazy, right? It's like, I don't know how to do this. But if I change it to a substitution using a U, I do know how to do this, right? It's just a factoring problem. Do you see why we did that?
Yes.
Any other questions? So you would have two answers for this one. All right, so I think that's enough for this section. There's a couple other ones that I skipped here and there, but there's a lot, and I think it's too much for one night. I need you to process this, practice, and go through it. And if you haven't started the homework, then that's okay. So you'll get to this once you finish the first two sections, okay? Because I sent you the recordings for 1.4 and 1.5. This is the third one. Tomorrow, I'm gonna try to send tomorrow or the day after. I'm gonna send you 2.1. 2.1 is super short. Um, 14 Alex Pie. I don't understand the question, Jonathan. Let me pause this.